Thank you guys for staying. I know it's the last talk of the day and there is no natural light. So, I'll try to make it as high energy as I can so as to keep everybody's attention going. As most of you, dare I say all of you will, at some point you'll be able to put this and you will be able to get rightfully mad when you put that on an airline and they say Mr. instead of Doctor whenever they tell you to please move away from the first class seat because you've only paid for economy. Anyway, so I was in iGGi. Look at that, me conveniently sitting near the center, looking at the camera. There's a bunch of other familiar faces. That's James, my supervisor. I had many more things of oh, look at this guy. But then I realized I'm already probably going to be over time. So let's get right into it. So that was me in iGGi 2019. And now, after iGGi, I was fortunate enough that as I was writing my thesis, because of a internship that I did with SIE London, and I'm not going to point you with the laser because that's dangerous, but we have Ryan over there, who is also now working for SIE London after his PhD as well. So I did an internship over there, and then through that, I crawled my way into Sony AI, which is essentially you have Sony, and they want to do AI, and then boom, Sony AI happened. Which essentially, in 2020, there was a company called iGGi that was bought, renamed, and now there's a bunch of us. There's people doing imaging and sensing, so the autofocus on cameras, robotics, scientific discovery, AI for creators, helping them with the mixing and stuff of songs. But personally, I think that the best one is the one over here, which is the gaming and interactive agents. There will be a lot of low-quality memes in this talk. I do not apologize. Now, this is me near the center, conveniently looking away from the camera. Oh no, did my laptop crash? Or do I just have to? Thank you.
I found a button on the remote that switched the screen off this morning accidentally. So.
Okay, I may need to come here every 2 minutes and just move it in case. But it wasn't. Anyway. So yeah, now that I'm working with all of these fellows, what am I doing? So first of all, oh wait, sorry, I had a meme anyway. So what do we do over there? So we mostly work with game studios. In this case, what I'm going to be using as an example throughout the talk is Polyphony Digital, which are the people that make Gran Turismo, which is a racing game, which we'll get to in a minute. So we work together with game studios to essentially help them make games better, and you can reach out to me after the talk to get a lot of technicalities on that, and also with gamers. And what I mean with gamers is that we want to get AIs that we train into the game so that players can play with or against them. So it's not only how can we make games cheaper to make via using AI, we ultimately want to make games better so that players can enjoy it. The way that we do this, at least within Sony AI, is my beloved reinforcement learning loop that we have going on. And if you've spent more than 2 minutes next to me, then you probably know what reinforcement learning is. If not, it's pretty simple. So there's the idea that we're going to train an AI agent by having this agent observe the world, and then it's going to take an action on this world. Then the environment is going to take this action, update itself magically, and give a reward to the agent. So if you're playing chess, this will be the agent observes the chess configuration, makes a move, and then let's say if it loses, it gets a -1. If it wins, it gets a +1. If it doesn't do either of those, it gets a 0. And then the environment gives back the next board configuration for the agent. Let's say if this was chess. This over here is the Gran Turismo logo, which is the racing game, and the little heart at the top is going to be the logo for GT Sophie, which is, spoiler alert, is the AI that we trained for Gran Turismo. Now, this is just me picking up the first machine learning slide from the internet, because something that I want to bring about is that, as many of you probably know, there is three main types of artificial intelligence that goes on within the machine learning world, which is supervised. You get photos of cats and dogs, and they tell you this is a cat, this is a dog. Now figure out how to train a discriminator, so it tells you it's a cat or a dog. Unsupervised, we have all of this data. Can you find clusters in this data that may be useful for us? And then you have reinforcement learning, which is learning from trial and error, as I've described. Now, it's a beautiful age for working in AI. Everybody loves us. Everybody thinks that we're saving the world, that we're making everything better, and we're making things cheaper. So I wanted to just make a small point in which why I think that reinforcement learning is I don't want to take the moral high ground, but I just think we haven't been as corrupted as many of the other types of AI have been. Happy to share the memes later as well. You don't need to take your phones out. Anyway, so modern AI is very good within distribution. What I mean by this is that if you have a lot of data, let's say all of the internet, and you train a model, look, that's the internet, and this is a distribution of things within the internet. Let's say you get all of the text on the internet, and you want to train a model that predicts the next word that comes up, giving a previous set of words that happen, something like any LLM nowadays, which, again, respect to the people developing those in the sense that, like, technically speaking, impressive things on many capacities. And the thing is that if you train, let's say, an LLM, you have something like ChatGPT, because it's ingested all of the internet, then therefore, whenever you ask it anything, like, oh, solve this problem, or like, here's like a riddle for you, oh, you're so smart because you've solved it. Well, you're essentially asking it to do something that it was trained on. And through all of these decades of AI evolving, now AI is very good at doing things within distribution. And even if, you're talking about, like, you prompt, maybe if you prompt, let's say, ChatGPT about, like, tell me about this one game that came out, like, 1 year after you were trained, then it's not going to be good, because it's not going to give you a nice answer, because it's something which is out of the distribution that it was trained on. Now, when it comes to reinforcement learning, let's say that you also had a bunch of data. Let's say you have a lot of players. They're playing League of Legends. They're probably hating themselves, as they were saying over there. This is not the opinion of my employer. So, you have a game, and let's say it's version 1.0, and then suddenly version 2.0 comes across, and version 2.0 has different dynamics. A new weapon was introduced. Some numbers on were put up or down based on some, like, business decisions. Now the agent that you trained at the beginning, which was trained on a specific distribution of, like, that quote-unquote game, then you wouldn't really be able to use it anymore. And so why I think this is good is because normally for these, like, out of distribution alert, normally on these other things like ChatGPT, etc., a lot of these, like, large models is kind of questionable. Again, not my employer's opinion, but my personal opinion is that it's questionable whether that data was taken legally, and even if it was taken legally, was it taken ethically? I think that we're not as corrupted in reinforcement learning because we generate the data ourselves. Like, within the simulation of, let's say, a video game like we do at Sony AI, we generate all of the data, and then ideally, we're not exploiting other people's labor. So I should have said this at the beginning, the talk is called the Joys and Woes, and I hope I'm pronouncing that second one right, of making AI for AAA games. So the first joy, we're not exploiting other creators, yay, which is as of today, because something may come about anytime soon. But the bad thing is that nobody will really know the difference, and then they're like, and then they come to me like, you're like making the games more addictive, huh? Yeah, you just want people to give you more money. And I'm like, well, I mean, I do want people to buy the games that I work on, but anyway. So, moving on. I'm going to be talking about this publication here, this Nature publication, which is outracing human champions in the game of Gran Turismo. The idea is that we got a Gran Turismo developed by Polyphony Digital, which is a first-party Sony studio. Some people are obsessed with this game. Like, I respect it personally. I am more of a Burnout or Jack X, if you guys are old enough to have played that game. So like, not the realistic scenarios, because this is essentially like a physics simulator. They got like slipstream going on, so you get like less air if you're behind one car, and there's just like all sorts of like really complex dynamics, and also it's like a multi-agent setting as well, so you gotta take into account like other players and how they react. So it's like a whole ordeal. So as Cogitai was bought and turned into Sony AI, then the higher ups in Sony were like, we'll believe that reinforcement learning is something that can be used for us to make games better if you guys show it to us in some capacity. So people early on in Sony AI, they said like, well, how about we make an AI for Gran Turismo and we defeat the human champions at Gran Turismo, meaning that like we make an AI that is able to beat the best in the world, which funnily enough are a bunch of teenage Japanese people that are not even legally allowed to drive. And I don't know, it's like good for them. I'm sure the average age of the best Smash Brothers champions is even lower. And so the way that this worked is that there were two events, the one in July and the one in October. I'm not going to get into the specific of which one was which, but it was essentially 3 races on each one of them, on 3 different three different tracks with different cars on each. So like these were competitive races, meaning that like everybody had like the same car, etc. So it was an even ground in terms of the capabilities of the cars that were used. And now, for the next little while, I'm going to be telling you, oh yeah, so another one of the joys, interacting with gamers and game developers. So it's cool, like as I'm working in Sony AI and with my colleagues, that we get to have talks with people that are making games. And it's like, wow, I admire you because I play games and I take enjoyment from you. And then they're like, I admire you because you know math. And I'm like, okay. So how does it go? So the AI that we trained to be disguised was called GT Sophie. Now, how does this go? Well, we had like 3 challenges to solve for this. The first one is, well, we're doing like we gotta figure out how to get a race car to go to the finishing line fast. So there is like really fast control that needs to happen. Also, this is running on a PlayStation, which is not really waiting for us to give them an action. It's like, I'm a game and I'm running. Like, if you want to give me a control, sure, but otherwise your car is just going to be staying there. So we have latency issues to take into account. We have racing tactics, and then you start getting into like game theory and a bunch of other cool things to take into consideration, and also the racing etiquette as well. So in the game, you can just like bash against people, and that's allowed, but that would disqualify you in an actual race. But this disqualification in an actual race is not something that happens within the game. It's like a social etiquette that is kind of outside of the system. So we had to figure out how to get this working for a reinforcement learning agent that just sees like positive and negative rewards. Now, how do we go about this? So yeah, one of the joys is that by playing, again, not the opinion of my employer, one of the joys is that like I enjoy playing games, and now I get to, when I play a game now, I'm thinking to myself, oh, like what would be like a challenge if I wanted to train an AI for this? And I feel like much if you buy a camera and you start taking pictures around, and then you look at a sunset and you're like, oh, this is beautiful, and you get to understand its beauty through the way in which you would capture it through photography. I feel that in games there's like a similar thing. Like I find an extra joy in playing games because I get to develop AI that play these games. Now, how do you reinforcement learn this thingy? So we gotta take into account the state, the reward, and the action, which we will walk through little by little. So first of all is the state. What is the agent going to observe such that it takes an action? It's like, well, you know, easy. We have a car, and a car has like 4 wheels, so we can compute the load on each wheel and also the speed, but the speed of the other agents as well, and like maybe where you are in the road, and also maybe like the temperature of the wheels, and like how much fuel you have left, and also yeah, the angle of the wheels as well, and like has anybody contacted the guy at the studio to get any of this in the code? It just gets too much. It's like a lot of information. So one of the woes of this is just like there's a lot of ad hoc engineering that nobody likes, but it's necessary because, you know, the agent needs to observe what it needs to observe so that it can do what it got to do. And you know, some of the smarter folk around you would be like, hey, excuse me, why don't you just learn from pixels? You know, like we humans learn from pixels, and like we play through pixels, and it also would be more fair if we learn through pixels and the agent also plays through pixels. And I'm like, well, first of all, nice Karman impression, or however this guy was called from Jimmy Neutron. Secondly of all, we have done that. We have like superhuman agents that are able to play with vision, but there is like some unfortunate realities of this. So one of them is, if you're learning through vision, good, but the game changes under the hood. If you're working on a game that is being actively developed, the textures are not going to be there, and they may change super quickly. So you're going to have an agent that may be overfitting to the way the game looks at some point, rather than the underlying information that is going on. There is other issues as well that happen when you're actually doing what I was describing here, of like the specific information, because you have to do iterative like API changes and like requesting things from game developers that may already be overworked, etc. So like nothing is ideal, but for now, one of the benefits about this is that also if you have pixels, then that means that you're rendering the game. And if you're rendering the game, it means that you probably need a GPU to be rendering the game, and GPUs are expensive. So what normally happens is that if you just get information from the game directly, let's say through an exposed API from the game, then you can train headlessly, meaning that you don't need to render the game, and you can probably like speed the game up quite a bit, so that you can just like maybe play the game, or the agent can play the game 5 times faster than it would if you had to render. So, although I have to say headless training is also horrible, because the way that the game behaves when the game engine is not rendering kind of changes the way that the game logic works, because game engines were like never thought that somebody would play a game without it being rendered. I have a lot of really funny stories from this, but for another talk, just find me later. So anyway, what about the action? Way simpler. So for the game of Gran Turismo, as easy as this. You go -1, so you have essentially like a vector, 2 little neurons at the end talking to each other. One of them says -1 is steering to the left, +1 is steering to the right, and similarly for the brake. Now, that probably means that we have a lot of very sad PlayStation 5 controllers sitting around being like, oh, you're not using me, you know, like you're not even using pixels and you're not using the controller. Are you really working for Sony? And this is just to say that like, you have to find the simplicities, you have to use the simplicities where you can find them, because otherwise things just blow out in terms of complexity. So in this case, for this specific thing, this will not yield a agent that is able to play every single game at every single point in development, but this just simplified our life when we were training an agent to play for Gran Turismo. So now we get to the reward part of things. So every action that the agent takes in an environment will receive a reward. What do these rewards look like? Well, on the one part, we have the normal rewards, which are like, you know, are you making progress through the track? Are you, what do I have written here? Are you going off course? So you may want to go off course a little bit to like kind of cut some corners, but you don't want to be like touching some areas which are not the asphalt, because you may get penalized in terms of like the competitive score, and also it slows you down, and then a bunch of other things. Where it gets interesting as well is that you have to add a lot of like kind of what I said before, the racing etiquette rewards. So, you know, the game is going to allow you perfectly fine to like collide against other cars, but you don't want that. And at the end of the day, you're going to be adding a lot of reward parts for everything, and you're going to have some convex combination of all of these reward parts into the final reward that the agent observes. You can be fancier as well, but for the sake of the talk, this should do. And now, look at this. Boom, numbers, a lot of them. There's not even a title. What is this? This is a set of rewards. One, that's a lambda. I said no math. Actually, that's a delta, never mind. So what I want to do with this is one of them, what I want to do with this table is, first of all, like low-key, really bad intimidation check. Because what I want to show is that there's a lot of reward parts, and this is not even all of them, that we used, as I was showing with pictures before, to train the agent. And on the right here, we have, so there's 3 columns. As I said, for these events, we played on 3 different tracks, which are called like Seaside, Maggiore, and Sarthe. I don't know how to pronounce it. For the French in the room, please do let me know. And like they have different reward weights, and we had to tweak some of these reward weights. This is, for me, one of the main reasons why reinforcement learning is currently on the research rather than the development side of research and development, because one of the woes is that we have to do a lot of reward hacking. We're getting better at this, and there's a lot of improvements that we have, and there's ways in which you could automate this, and then like Simon Lucas is going to be like, well, have you tried in TBA? And there's like a lot of beautiful things that you can use. See, I was in iGGi. So yeah, but unfortunately it's a reality that we have to live with, which is that we have a lot of reward parts. Ideally, we just have a reward for like, are you winning, son? Are you losing? But we're not there yet. We're working actively on it. Anyway, how am I doing with respect to time? Probably bad. Let me quickly check on my phone. When does this fit? No, we could. Okay. Wow. So we have this whole thing. Like we have an estate that we're observing. We're taking some actions. The environment is not crashing. But that's mostly because PDI are wonderful developers and their physics engine works great. For the most case of most other games, that might not be the case. And the agent is able to observe a reward. Nice. So what do we do next? And it's like, well, you code it, right? And then you launch the experiments and you do the things. And I'm like, oh, that's great. I love wasting University of York's resources. And now I have even more resources because I'm in the private industry. Great, so once again, thank you, Ryan, for Sony Interactive Entertainment for essentially lending us a lot of PlayStations to do things with. So how does this work on the highest level possible? Well, to train the agents that we deployed for the last event that won against the human champions, we had 20 PlayStation 4s that are running the game. Also, something that I forgot to mention before when I said the thing about learning from pixels is that especially on a multi-agent thing like Gran Turismo, you can have at most 20 cars in the environment at once. So if you're learning from pixels, it means that for that one race where there is 20 cars, you can only get data points for one of the cars. But if you're training headlessly or, well, it can be rendered, but if you're training from data that you surface from a game API, you could actually have for every frame of the game 20 data points, one for each car. So yeah, it's a battle that we need to fight, how to maximize resources because resources are expensive. And as much as I love reinforcement learning, it is data hungry. It is not very sample efficient at the moment. So anything that allows us to get more samples, we need to take it. So, and thank you, computer, for not crashing like you were doing before. So we have 20 PlayStation 4s, and each one of these PlayStations is essentially connected to what we call a rollout worker, which is essentially just a CPU that is hosting the agent. Note, we host the agent on a CPU. We don't have a GPU for the agent, and this will become, I'll talk a bit more about this later. And then the agent is observing the state, observing the state from the game, and then is taking an action. And then the reward is also happening over here, but I just didn't put it. So we trained for 2 weeks straight. That was for becoming better than the best humans. It would be significantly less to just like beat the average person. And then all of this is being fed into like a data set that in the realm of reinforcement learning is called an experience replay buffer, which is essentially just like a growing data set that contains all of the experiences collected by the rollout workers. And then that's where the magic machine learning happens. For the few of those that care, we were using a distributional version of soft actor critic or SAC, which is like a reinforcement learning algorithm that has some entropy regularization so that it doesn't overfit too much to a specific action, because it also like uses the entropy regularization to like dissolve the probability of taking any action across all actions, sure, yada yada. We train an agent doing this, and then essentially the trainer is like constantly updating, and the rollout workers after every episode are like, hey, do you have a new model? And it's like, yes, here's a new model clock for you. And then it like updates the model clocks of the rollout workers, which in turn collect new data, etc. This is beautiful when it works, and when it doesn't work, it's horrible to debug. But when it works, it works. So, for those counting, this is the joy number 4 of working on this, the computational infrastructure for training though, because for inference, it's a pain. Why is it a pain? This is a PlayStation 5 Pro, it's Pro because it has a strong ARM. So I say this is woe number 5. There's more woes than joys currently, oh no. So why is that the case? So why is it the case that this is bad? It's bad because we're running, in the case of Gran Turismo, we're running our agent on device. And I love consoles. The console cycle takes a while to happen. You know, it's every, I don't know, like 8 years or so. And so it means that like the hardware remains static. Game studios, traditionally speaking, and even to this day, have not really cared about AI at all. So like, you know, if you say, hey, here's a GPU for you, my boy, you're going to be like, oh, thank you very much. I'm going to be using this to have the best graphics that I can because it's called a GPU, so I'm going to get that G really going for what it was meant to be. I'm not going to give you some space to run your AI model. Like, why would I be doing this? So we have to really optimize a lot, and this was not me. Somebody who is like a genius in C++ in my company was doing all of this. You have to really optimize the agents that you have to be able to run on the old-fashioned, like on the perpetually aging hardware that you have. So that's not great. That's why I say it's a woe. And also, look at this: 4 intermediate, like 4 deep layers, 1 input layer and 1 output layer. That's it. This is it. Like this is the size of the neural network that we use to beat the best human champions. If you read papers like the StarCraft 2 paper, or like the Dota 2 paper from OpenAI that like train models to be the best humans, they are like gigantic models. And respect to those that use gigantic models to do gargantuan tasks, we just don't have that luxury. So that's something that arguably is something that I enjoy about working in the company. I don't personally love tuning the actual architecture. I prefer like focusing on the reinforcement, like the more theoretical aspect of reinforcement learning. But like this tiny neural net, which is smaller than the ones that I was using during my PhD, is what was used to beat the human champions, because we just did not have that much compute. Also, as I mentioned before, we're running this in real time, so the latency has to be like super quick. All right, what next? We get to the fun parts. We get where this is where the videos begin. So this is an agent. It was just like trained on time trial, meaning you just have to be as fast as possible. And you can see how the agent is essentially, if you've trained reinforcement learning agents, this is not a surprise for you. It's like really like overfitting to try to do what you told it to do, because it's a reinforcement learning agent. Why would it generalize to anything else? Even if you really wanted to generalize to anything else. So that's nice. Also, you get things like this. Let's say if you tune the reward to like drift, and I'll give you a cookie, then it drifts. But you're also giving it cookies by finishing the match, like finishing the race and being quick. So, you know, it's cool. You train like 20 agents, 19 of them fail, but one of them has the right weight on the drifting reward, and then it's just, it's great. It's great. I asked, like, can I show this video, please, 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 and they were like, yeah, sure. Technically, you can do that if you're human, but I was looking at the logs of the actions that it took, and it's like way too involved, like the way that it was kind of breaking and doing things. So yeah, one of the joys, I have a clicker, what am I doing next to this? One of the joys of doing AI for AAA games, whatever that was, right? Whatever that was great. That made my day back in the day. But yeah, as I said before, it's a multi-agent environment. So, that's kind of the part that I quite enjoy the most doing my PhD, is the multi-agent aspect of deep multi-agent reinforcement learning. And something that I wanted to show is this graph, which has things, and those things are axes. Okay, so specifically we have on the y-axis, we have this thing, which is questionable collisions. You don't want collisions in the game, so lower is better. On the x-axis, we have the team score, and as Ocean was saying before, team score, like scores are like points, and we like points in general. So higher is better. So ideally, you want to be where this blue line is on the baseline. And so what this graph shows, the points specifically, is we're going to get an agent, like a GT Sophie agent, and during training, we're going to be changing the population that it trains against. So what are the other agents in the environment that it trains against? So let's say that we're training against the built-in AI. The built-in AI, to simplify things, it's somebody from PDI, from the company, just like took one car, and for every track, it just like went around the track. And then it doesn't matter so you get that data, and then there's a basic controller that essentially doesn't matter what car the built-in AI is playing, is going to always try to match that same line that the developer did. And this is bad because like some cars should drive a different line than other cars. That's kind of half of the beauty of this game. And also they have some built-in things, like if you're getting too close to them as a player, they're going to like move away from the side as to be conservative and avoid collisions. And the thing is that if you do that, then the agent is going to embed within its weight the fact that you can be aggressive. So now all of the videos that I'm going to be showing from now on are videos from the events that happened, where we played against, those neural nets, played against the Japanese drivers. And then, so for instance, the videos are not going to be coming specifically from the AIs that generated these data points, but it's kind of to show you what this behavior would look like. Like, what does overconfident and aggressive behavior look like? It would be something like this. So, you're kind of going around and you're doing this, and then the other drivers, which you can see with the Japanese flag, are like, that's, that's a short video, so I'm just going to play it again. Which in this case is like you're hitting other drivers and you're being disqualified, and also like this is not nice. We don't want our AIs to be doing this. Now, what happens if you play against aggressive opponents? So opponents that will like kind of try to hit you and like will not, even if you would like be overtaking them, maybe they would like try to hit you against the wall. So that's bad. If we train against this kind of agents, then we get this sort of behavior, which is a bit more subtle. But the idea is that here, this Sophie Orange is got the lead, and now there's this guy behind him on the slipstream, and it's just kind of, like, our AI is Sophie Orange, is just staying there, and then this other guy just like overtakes him. So there's no actions taken. I'm gonna play it again. There's no actions taken by the AI to like prevent the agent, sorry, the Japanese driver from overtaking it. It's just kind of like sitting there and waiting for like life to go by. Specifically here, you can see there's nothing happening, and then this guy is like, okay, sure, I had the slipstream, so I have more acceleration than you, I'm just gonna go over. And you're like, why did this happen? Then you start looking at a video of what happened, and you see this little icon. This icon means that the brake was activated. So in this case, the brake is being activated. There was nobody behind them, because now the Japanese driver is on the right. So it's like, why are you doing this? And so, I mean, it's a neural net, we can't say for certain this is what happened, but the idea is that because if you train against aggressive drivers, then in situations like this, you're gonna be like, oh no, I'm gonna stop right here, like in case that something happens, because I'm gonna get a penalty if I get hit. So this is also one of the woes when you train these agents, like you get the reinforcement learning problem and you define it within the realms of all of this, and you get the rewards and you code the rewards and you get the observations from the game and you get the neural network to be fast enough to run in real time, and you contact the Japanese drivers and you get them to come here and you do all of these things, and then stuff just like just fails sometimes, and it's annoying because you've put so much effort and this is like clearly such an quote-unquote obvious thing. Why are you missing this? You're so good at so many other things. But and self-play is my favorite word in the academic world. If you are smart about which opponents you play against, and you do a mixture of aggressive opponents and the built-in AI and selected previous versions of yourself, and when I say yourself, I mean like previous model clocks of the training agent, then it works and you get things like this. So here's like one driver at the front, there's a Japanese driver that overtakes this Sophie agent, and then in this one thing, these two Sophie agents simultaneously overtake two of the best human drivers in the world. If you don't play racing games, this just feels like a normal thing. There is no like turtle shells hitting other things. But this is big, like doing something like a double takeover and then two cars doing a double takeover at the same time against some of the best people in the world. This is great. So when you get things right, it's great. Like it's a roller coaster doing AI for video games, but yeah, when it works, it's truly inspiring. So moving on, it's great. We won against the best humans in the world, but nobody except for us, and I guess the Sony executives truly cared. There was some fanfare that happened, and some people were impressed by it, and like the Gran Turismo, the developers kind of like put up like a blog post and a little movie and a bunch of things, which is great. But ultimately, I didn't get into this, so I could have like a nice paper that says we beat the best in the world and then move on to something else. Actually, yeah, personally again, not my employer, but when OpenAI did a thing with Dota 2 and then they trained those agents and then nothing came out of that. And then when DeepMind did the agent for StarCraft and then nothing came out of that, I was a bit disappointed because in my head it's like, if we waste a lot of money to do these things. Like AI is expensive. And if we just do it so we can then get even more money from some other investors to do some other thing, it just feels like a waste. Fortunately, at Sony AI, we're not the best in the world, but we do try to productize some of this. So a year and a half or so after that event, there was a small thing where it's called Race Together, where there were like 4 different, how am I doing on time? We did like a thing where like a very constrained setting where you could choose one out of these 4 races and just play, and then all of the other agents would be GT Sophie agents that we trained specifically for this. And this only lasted for a few weeks because we wanted data. Not to train agents, but we wanted to see like, did people like it? Did the agents completely crash? Because we were opening this to like millions of people playing Gran Turismo, because again, there's a lot of people that are really obsessed with this game. And that's one of the joys of making AI for AAA games. When you go live, when you go to production, when it's out there and it's like you send your kid to uni and then it's a popular kid and you're like, yeah, and then they join a hip hop dancing club. And anyway, so just a couple quotes. So something that I wanted to say is that, so as this guy from GT Planet, which is essentially like a website that has a lot of news and interviews and stuff about Gran Turismo, they said, it reminds you how dull and lifeless the standard AI is. And I wanted to put this one up because AI for games is, when people say play against the CPU, the bar is rather low. It's hard to make a hand-crafted controller to do interesting things, and that's kind of like, that's the niche that we're trying to creep up on. And it's great that then we see that stuff that we do, it seems to blow the built-in AI out of the water, which is great. This guy on Reddit was overly excited, and I was like, oh man, I can't wait for this to have like different levels of difficulty, etc. So we're like, okay, that's something that people want. So people want to have like their difficulty like scaled up and down. Ideally, how we could go about that has many shapes and names. But this is one of the cool things about having these limited time events, that you can get like user preferences that they may tell you in advance, I want A, B, or C, but it's not until they get something. It's not until you do like a small event that then they actually are like, well, what I want is D, F, and G. And also, this is something that was cool. So the idea of like keeps the pressure up without driving dirty. And this is nice because the built-in AI, as I said before, was like overly conservative and in trying to avoid all collisions. And the fact that we were able to do something like this, it was great because it took a lot of reward hacking to make sure that our AI wasn't just like savagely ruthless. Anyway, to experience positive player reactions, there's a bunch of stuff that is bad as well that some people didn't like, but we found that it was like honestly overwhelmingly positive, and that was great because it takes a lot of effort and time to do this thing. So to understand that some people actually do enjoy it and it makes their experience better is kind of like the whole point. But you only get that end of the reward cycle, of the feedback cycle, years later. So proud that we actually got this working. Then at some point we made it a permanent thing in the game with this like Gran Turismo Sophie 2.0, but it was limited to like a certain amount of cars and a certain amount of trucks, and then we were like, how about 2.1? And as you can say, PlayStation 5 only because we couldn't support this on PlayStation 4 because even for our tiny neural networks, we just didn't have the space. So PlayStation 5 only. More cars and more trucks and custom races. And this is only gonna get better. So we're continuing to work to expand to more cars and more trucks, and it's pretty cool because this began as like a bunch of people way before I joined, a bunch of people essentially hoping to make something out of reinforcement learning, and then they got bought by Sony, and all of this happened, which is honestly quite cool. So a lot of people were part of the Game AI project, and so the final joy of all of this is to be able to stand on the shoulders of giants and like collaborate with a lot of people that I do admire and that are really good at the job. I would point out specifically, if you ever watch this recording, Tom, which you probably won't, that's my boss, and this guy is great. And this guy is like, he was the CTO of Sony, and he's like way too funny for how much of a strong accent he has. Please do not watch this, Gitanos. So yeah, thank you for coming. I hope I woke you up a little bit. And if you're interested, we have internships up. So yeah, thank you everybody.